Lively Ho students, Mr. Kaczynski with you. We're going to do the practice your skills problems from section 6.4 of our book, which is scientific notation for large numbers. So we're going to write each number in scientific notation. So we got this huge number, 34 billion is how it's read. Let's go. So scientific notation is always written in this form, where the first factor is a number between 1 and 10, or between -1 and -10. Kind of stating that a little bit loosely, but that's about the gist of it. And then the second factor is a power of 10. Now, to get that power of 10, it's how many times would we have to multiply 3.4 by 10 to turn it into 34 billion? Well, we'd have to multiply it by 10. Let's use a different color here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So some people make the mistake of just counting the zeros, but it's really more about counting number of times you got to multiply by 10. So 3.4 times 10 to the power of 10 in this case, and that equals 3.4e10, which is the calculator's way of stating 3.4 times 10 to the power of 10, or 3.4 if we use a recursive rule, times 10 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. On the 10th time, it's where it turns it into scientific notation, because the calculator can't hold that many decimal places anymore. Let's do it again. So like I said, the first factor in scientific notation is always a number between 1 and 10, or in this case, -1 and -10. The second factor is a power of 10. And then we just got to count how many times. 1, 2, 3, 4, 5, 6 times. There it is. So -2.1 times 10 to the 6th. Let's do another recursive rule. -2.1, enter, times 10, once, twice, 3 times, 4 times, 5 times, 6 times. There it is. So we got the 1, 2, 3, 4, 5 zeros, just like here. There's also a way to turn it into scientific notation on your calculator. Let's see, mode, scientific, enter. Go back to the main screen. There it goes. It turns that number into scientific notation for us. I'm going to turn that mode off though for right now. But again, that reads as -2.1 times 10 to the power of 7. All right, don't round too much on this one. We're going to keep all what we call the significant figures. That's the numbers that aren't zero and the numbers in between those non-zero numbers. Times 10 to the power of what? 1, 2, 3, 4. 1.006 times 10 to the power of 4. 2.5 times 10 to the third power. -1.52 times 10 to what power? 1, 2, 3, 4, 5 zeros plus the 2 and the 5 makes 7th power. And okay, well, first of all, 25,000 squared. Well, I can do this without a calculator because I know that 25 squared is 625. And when I square 25,000, I'm going to go from having 3 zeros to having 6 zeros. So this is really the number that we're turning into scientific notation. I'll show you on the calculator as well. 25,000 squared is actually that. Okay, so I want this to be 6.25 times 10 to the power of 368. There we go, 6.25. If you hit second and the comma button, there's times 10 to the power of, and you can just put the 8 in, and it turns it into 625,000. All right, next up, we're going to go from scientific into standard now. Okay, so we're going backwards. 7.4 times 10 to the fourth. 7.4 times 10, 1, 2, 3, 4 times. There it is. I don't think we need the calculator anymore though, because you can see that you just got to move that decimal place to the right 3 times. Beyond the 4, that's 1 place, and then add the 3 zeros, that's 4 total places. So this 4 right here, there's the 1, 2, 3, 4 decimal places right there that it had to move. So this is going to be -2, and then we got to move the decimal place 6 spots to the right because we're multiplying it by 10 6 times. So -21, -213, -2,134. We've multiplied by 10 3 times. Now we need to multiply by 10 another 3 times. Some commas really help that to be easier to read. Let's check and see if that works. -2.134, enter, times 10 6 times. 1, 2, 3, 4, 5, 6. There we go. So this is 4, and then the 0, 1, that's 2 places, and then a third place. So 4,010, -7 point, no, we don't want the decimal point. 1, 2 places, 3, 4, 5 places. 1 times 10 to the 9th, well, that's 1 billion, because 1 times 10 to the 3rd is 1,000, 1 times 10 to the 6th is 1,000,000, 1 times 10 to the 9th is 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably should be typing these. My answers would be a lot neater to read. And -1.084 times 10 squared. This is, we got to move the decimal place 1, 2 spots. So this is actually still a decimal. You're only multiplying it by 100. That's what 10 squared is, which is going to move the decimal place 2 spots to the right. All right, last thing. Owen insists on reading his calculator display as 3.5 to the 7th. Let's write that down. 3.5 to the 7th. So he thinks that that calculator is doing this operation, and that's what that answer means. Okay, he's actually got 3.5E7 showing up on his calculator. Bethany tells him that he should read it as 3.5 times 10 to the 7th. So she says he should read it as 3.5 times 10 to the 7th. He says, they are the same thing. Why say all those words? Write Owen's and Bethany's expressions in expanded form and evaluate each to show why they are not the same thing. So here's Owen. Okay, it's 3.5 times 3.5 times 3.5. There's 3 of them. 4, 5, 6, 7. Which when we evaluate that, let's get rid of this here. Let's go 3.5 to the 7th power. That is about 6,434. Let's just say that. Now this one, Bethany's, is 3.5 times 10 7 times. So times 10 times 10. That's a bigger multiplier, isn't it? 3, 4, 5, 6, 7. So 3.5 times 10 to the power of 7. That's a slightly different thing there, Owen. 35, how many zeros? 1, 2, 3, 4, 5, 6. 35 million. A little bit different. So Owen, not quite, buddy. By the way, I had the 3.5 and then second comma, or second, which puts that E in, which the calculator knows now that's times 10 to the power of blank. I'll put in the 7, and there it is, the same number, okay? All right, that's it for the practice your skills. Hopefully that helped you identify some misconceptions. I am here, and please ask questions if you have.